and today I will be presenting my participation at SemEval-2022, where I participated in tasks 2, 3, 4, 6, 10, 11 and 12. I used an approach that is based on multitask learning. Now in early work in multitask learning we used to be very careful about which information to share, not only in the model, but also to select which data sets to select. More recently, autoregressive language models have been used with enormous sets of corpora that are all just trained simultaneously. Now this became possible because autoregressive language models have text as an input and text as an output, and these tasks were converted to prompts, so it's relatively easy to train on multiple tasks at the same time. Now I was wondering, can we exploit this pre-selected combination of NLP tasks in a multitask setup to improve the ability of an autoencoder language model to learn NLP tasks? So instead of an autoregressive model, I will be using an autoencoder model, which doesn't use a text-to-text format. I will be using the MaChAmp toolkit. As you can see on this slide, we have an input, then we have some contextualized embeddings like mbird, and in the end we stack some decoders on the top for every task. Now in this example we have a sentiment decoder that predicts that this sentence is negative, and we have a part of speech tagging decoder that predicts the part of speech tags. But in practice you can use as many decoders as you would like. In SemEval-2022 I used all the tasks that contain annotation on the word or sentence or paragraph level. We didn't use the document level or the other picture-based tasks because that would be non-trivial to implement. This is an overview of the tasks. More details are in the papers, of course. This is another view of these tasks. So in this table I list the dataset sizes. One thing we did to make sure we don't overfit on one task specifically is smoothing the data. So you can see that we used multinomial smoothing with a factor of 0.5, and you can see the result in this table. Furthermore, you can see the MaChAmp task types. So in MaChAmp you specify the task type for each task. And there are a couple that I want to highlight here. One is the task, the subtask 2 from SemEval task 3, which is a regression task, which we added for the sake of the shared task. We added this in the MaChAmp code. And tasks 10 and 12 are structured tasks. So here we use some tricks, and we actually use 3 task types to tackle one task. So I will show a little bit more detail, a more detailed example for task 10. So task 10 looks like this originally. So this is structured sentiment analysis, and we convert this to a sequence labeling task, as you can see in this example. So we we first identify all the entities, and then we identify the links between these entities as a sequence label. Note that these items can be overlapping, and they are bio-encoded. So we tried to do normal sequence labeling, we tried to do sequence labeling with the CRF called SecBio in MaChAmp, and we tried multi-sequence labeling, but the simple sequence labeling task type outperformed the others, so that's what we used in the end. Now we're going to try multiple models within MaChAmp. So let's say we want to tackle SemEval task 4. In this figure we can see that from task 4 we can simply train a single MaChAmp model if we use the mbird encoder. So that's the single model shown on the left. Then we can also train a default multitask model where we use data from all SemEval tasks. So that's the one we call multi. And eventually we can also re-fine-tune this model. So we copy over the weights from the multitask model and we re-fine-tune it only for task 4 in this example. And we call that multi-fine. This setup is also called stilts. Now, if this is a bit unclear for you, I have a real-world analogy that might make it more clear for you. So in my opinion, multitask learning is a little bit like juggling. So if you're juggling, let's say you have one type of object, so these cups for example. Juggling is relatively easy, right? But now if you want to do multitask learning, you have a different type of object. So we have a cup and a doll. Now this becomes much harder, right? Because they have different sizes, so you can see I'm struggling here already. Now, what our final multi-fine model is actually doing is it's training to learn to juggle with different types of objects, a lot of different types of objects. So can imagine, for example, these 4 objects, very different datasets. Now, if I learn to juggle with these, and then I go back to juggle with only one type of object afterwards, you can imagine that it becomes very easy and I will be extra good at it. So that's the intuition behind the multi-fine model. In practice, in MaChAmp, it will look like this. So this is a JSON file describing one task. Then we want to train the 3 different models. So the first training command is for a single task model. Then we have the multitask model, where we train on all JSON files at the same time. And then eventually we re-fine-tune on the second model again. These are the results. So we can clearly see that for different tasks, different setups are optimal. Unfortunately, I couldn't find a real trend on when to use which task. Interestingly, even the single task baseline outperforms the others at some points, and the multi and the multi-fine seem to be competitive on average, but for some tasks, one of them is much better than the other. These are the results on the test data. The rankings are not very high, mainly because I didn't do much tuning, so let's skip over this. And here you can find all the code, as well as the multitask models that you can reuse to train your own multi-fine model. Thank you for your attention.